As we wrap up our discussion of integrative functions of the cerebrum, we'll do a quick examination of learning and memory and language. Without memory, we'd repeat our mistakes. If we worked a problem wrong, we may very well work it wrong again and again and again because we wouldn't learn from what we're doing wrong and be able to correct that behavior. On the other hand, we'd also be unable to repeat things that we do well, our successes and accomplishments. We wouldn't realize or learn how to do things successfully. Therefore, it would be much more difficult to repeat those actions. So learning and memory have been studied very extensively, but we still don't completely understand how we recall information or how we remember events, things that have happened to us throughout our life. We do know something, though, about how information is acquired and how it's stored, how the brain processes these things and turns them into memory. So before we begin talking about the different types of memory, short-term and long-term, we want to briefly examine language. In order for us to use language to communicate with each other, we have to be able to learn and to remember. All animals, or I should say most animals, I really can't say whether all do or not, but ants, birds, whales, snakes, humans have developed ways to communicate with other members of their species. All animals do it. Humans use language to communicate with each other, and that language can be vocal sounds, what we call speech, or symbols, drawings and writings that are going to convey information. So most commonly our language as humans is going to be written or spoken. The cerebral cortex, as we've learned already, contains two language areas, Wernicke's area and Broca's area. Wernicke's area is an association area that's found in the temporal lobe, and that's where interpretation of the meaning of words that you see written or words that you hear spoken is processed. So it basically just translates words into thoughts. Wernicke's area receives input from the primary visual cortex if we see written words, and from the primary auditory cortex when we hear spoken words. Broca's area is that motor area located in the frontal lobe, and it's active when you translate thoughts into speech. Broca's area receives input from Wernicke's area and then generates a motor pattern for activation of the muscles that we need to form the words. So think about all the muscles that are active in creating speech. So you have the muscles that are associated with the larynx and with the mouth, all of these moving, your tongue. So all of these have to be stimulated to move. So the motor pattern is transmitted from Broca's area to the primary motor area, which then activates the appropriate speech muscles. And then the contraction of those speech muscles helps you turn those thoughts into words. So let's look at the pathway of this, the neural pathway that's used when you hear or see a particular word, and then you want to repeat that word. So first thing, the information about the word is conveyed to Wernicke's area. If the word is written, Wernicke's receives input about the word from the primary visual cortex because we see the written word. If the word is spoken, Wernicke's area receives input about that word from the primary auditory area. Remember, auditory is hearing. Once Wernicke's area receives that information, it translates it into the appropriate thought. So we know what that word is because of that association. So in order to be able to say that word, then Wernicke's area has to transmit information about that word to Broca's area. Broca's area receives the input and develops a motor pattern so that the muscles needed to say that word can be activated. That motor pattern is conveyed from Broca's area to the primary motor area within the brain, which then activates the muscles of speech, and contraction of those muscles allows for the word to be spoken. Did you have any idea it was so complicated in order for you to see a word on paper and then to say it aloud? And although we've mentioned these before, I want to bring up aphasia again, A-P-H-A-S-I-A. So injury to the language areas of the cerebral cortex can result in aphasia, or an inability to use or comprehend words properly. Damage to Broca's area may result in what we call expressive aphasia, or the inability to properly articulate or form words. So people with this type of aphasia know what they want to say, they just have difficulty in saying it. Damage to Wernicke's area results in a different type of aphasia called receptive aphasia. This is characterized by a faulty understanding of spoken or written words. So someone with this type of aphasia may very fluently produce strings of words, but they don't mean anything when they're all strung together. It's what we commonly call word salad. So I may be thinking, could you please hand me a pencil? And instead I say, dog blue clouds, rain beach, pencil. Okay, so of course those are two very different types of aphasia that may result from injury to those specific areas of the brain. Memory is the process by which we acquire information and store that information so that it can be later retrieved. Short-term memory is the temporary ability to remember just a few pieces of information for a few seconds or a few minutes. For instance, if someone gives you their telephone number and you realize your phone is in your backpack and it's in the cubby at the back of the class, and you want to put that number into your contacts list. So you remember that number, you walk across the room, and then you punch it into your contacts. Now that may be forgotten within a few seconds because it's going to be just put into our short-term memory that can later be transferred into long-term memory, but we tend to rely on our devices such as our phone to be our short-term memory. So about 5% of the sensory input is put into this temporary little holding bin where we can either do something with it or forget it and it goes away. Long-term memory, on the other hand, is a more permanent type of memory, and that can last from days or years. Sometimes these last almost throughout your lifetime. So let's go back to that phone number again. For instance, if you got that phone number and then later you and this person became very good friends, and you practiced this phone number by entering it over and over and over again. Now we know we really don't do that. We just punch Joe's name in the contact list, right? But anything that you practice over and over and over is going to be repeated as your brain processes that memory and become a part of your long-term memory. So even though the brain receives a lot of stimuli, you normally only pay attention to a very few items that come in, very few stimuli that come in at a time. So it's been estimated that about only 1% of all the information that comes into your consciousness is stored as long-term memory. Your long-term memory has a limitless capacity, but those memories can be forgotten. So let's look just briefly at different types of memory. All right, remember, memory is the process where information is acquired, stored, and retrieved. So there are two main types of memory: declarative memory, which is sometimes called factual memory, and procedural memory, sometimes called skill memory. So factual memory is the memory of experiences that can be verbalized or declared. So events, objects, names, places, types of cars, colors. So this information of the memory requires that we have conscious recall, and it's stored in the association area of the cerebral cortex. So, for example, visual memories are stored in the visual association area. Auditory memories, your favorite song, are stored in the auditory association memory. Your procedural or skill memory includes things like the memory of motor skills, procedures, and rules, how to ride a bike, how to perform the steps of a dance that you learned, the memory of how to get into your car, turn the car on and start driving. So it doesn't require that we have conscious recall. It's just stored in the basal nuclei, the cerebellum, and the premotor areas. So these are things that once it's learned, it's hard to forget how to do these. You don't forget how to learn a bike. You may get a little rusty at it, but you remember how to do it. You always remember how to get in your car and to begin driving. You don't necessarily have to recall those steps. It is just that procedural learned memory. There are several factors that can affect the way that short-term memory is transferred to long-term memory. Remember, short-term memory, you remember short little chunks of information for short periods of time. And long-term memory is basically like going back into the archives of your computer and pulling up those files that you thought you might have forgotten. But there are several things that can affect the way this transfer from short-term to long-term takes place in the brain. If you think of a time that you were really scared or really happy or very emotional for whatever reason, you remember that, and therefore there's a lot of memories associated with that. For instance, you may have learned that if you pull out into an intersection when the light is red, other cars may hit you, right? So that's a very emotional state. You remember the time that you weren't paying attention. You perhaps looked down at your cell phone and you entered that intersection and you became very scared when you saw those cars coming to you. You may remember the color of your best friend's dress when she fell off the swing and broke her arm. You may remember the sound of your grandmother's voice the last time you spoke with her, because those are very emotional states. You remember the emotion with those memories as well. Rehearsal. This is something all students should be familiar with. The more you rehearse or repeat something, the more likely you are to remember it. Think back to elementary school. How did you learn your ABCs? How did you learn your spelling words? How did you learn your multiplication tables? Those mean old teachers made you write them over and over and over again. You had to say them out loud. You had to spell them out loud. All they were doing was causing you to rehearse those things, and they're still there in your memory. I'll bet all of you could tell me how to spell hippopotamus. Well, maybe not hippopotamus, but cat, dog. You remember what 9 times 2 is because you rehearsed those. So when you're studying for anatomy and physiology or for anything else, the more times you process that information, the more times it's going through the brain and more likely to be transferred into long-term memory. So this is often why I tell people, listen to the videos many times and take a new set of notes each time. You're processing auditory stimulus as you listen to my voice. You're processing visual stimulus as you are writing those notes on paper. Then you can take those handwritten notes and sit down at your computer and process them again as you input them into a Word document. Save them. Go back in. Start deleting things. See if you can fill those blank spots in. You've just processed that in many different ways. That act of rehearsal helps you to remember. Association is also a way that helps us to remember something, and this is where you associate a new memory to something you know already. For instance, if you are learning about antidiuretic hormone in Anatomy 2, and I teach you that this hormone is going to cause holes to be poked in nephrons so that you retain water. Well, that sounds like a really complicated concept until I give you an analogy of a water hose. And you know what a water hose is, and you know what would happen if we poke holes in that water hose, right? Water would leak out. Well, the same thing happens when antidiuretic hormone is secreted. So you're associating something new with something that you already know, and that helps you to get that memory into long-term memory. And then we have automatic memory, and this is information that's not consciously formed and much more likely to be more difficult to be retrieved. So these are things that we don't realize that we are processing this memory, but when we bring up other memories associated to it, sometimes this also becomes a part of it. For instance, I mentioned a while ago, you may have the memory of your best friend falling out of the swing and breaking her arm. You didn't consciously process that her dress was blue, but when you remember that event, you remember her dress was blue. You were much more thinking and remembering what happened to your best friend and the pain that she was in and the way that you felt when that happened and the way that she cried and all of the other events. But in your brain, you also processed her dress was blue. The hippocampus and the amygdala are part of the limbic system, what we sometimes call the emotional brain. So the limbic system ties memories to emotion and therefore helps us to remember things much more vividly. So any damage to either of these areas, of course, can result in memory loss, and in severe cases can result in amnesia. Amnesia refers to the lack or loss of memory. So it can be total or partial inability to remember things. Two different types of amnesia are anterograde amnesia, where there's memory loss for events that occur after the injury or the disease that caused the condition. So think of this as an inability to form new memories. In retrograde amnesia, there's memory loss for events that occurred before the trauma or disease that caused the condition. So, in other words, it's an inability to recall things that happened in the past. All right, that finishes up this chapter. I'll talk with you again soon.